nomenclature is one of the most important topics we will discuss. Chemicals are named in systematic ways to give you information about the formula of that chemical, so a good understanding of chemical nomenclature will be necessary for you to be able to identify compounds by their formulas and vice versa. Before we discuss nomenclature, we have to make the distinction between ionic and covalent compounds. For the sake of this discussion, we will make a distinction between these compounds by what is happening with the electrons. Ionic bonds are formed when one atom donates electrons to another, and covalent bonds are formed when atoms share electrons. Ionic compounds are formed between metals and nonmetals, so that is how you can identify them. Metals are found on the left side of the periodic table and usually form positively charged ions called cations. Nonmetals are found on the right side of the periodic table and usually form negatively charged anions. You can determine the formula of an ionic compound by determining how many of each ion is required to balance the charge and have a neutral compound. For example, the compound formed between magnesium ions with a charge of +2 and nitrogen ions that have a charge of -3 is Mg3N2. That is because you need to have 3 ions with charges of +2 and 2 ions with charges of -3 to have a neutral compound. Here are some other examples of formulas of ionic compounds. The number of atoms required will be the lowest whole number ratio of atoms to balance the charge. When naming ionic compounds, I divide them into 2 types depending on the identity of the cation. Type 1 ionic compounds are compounds where the charge of the cation is known. Because we know the charges of all the ions, we can immediately determine the chemical formula just from knowing the atoms involved. There is a pattern to follow on the periodic table to decide what the charge on a particular ion is going to be. Atoms in group 1 ionize to have a charge of +1. Group 2 has a charge of +2. Skipping over the transition metals, the column beginning with aluminum has ions with a charge of +3. Then plus or -4, then -3, then -2, then -1. The noble gases in the last column usually don't form compounds. When the cation is a type 1 cation, one that we know the charge of, we can simply name the cation and change the ending of the anion to have the suffix "ide" or IDE, and then we have the name of the compound. Here are some examples of type 1 ionic compounds and their names. Here I have given the names for 2 compounds and the formulas for 2 compounds. If the name is given, determine the formula of the compound by determining the charge of the ions and how many of each would be required to get a neutral compound. If the formula is given, name the compounds using the naming rules for type 1 covalent compounds. Pause the video here until you have arrived at your answers. When I mentioned the patterns for the charges of the ions, you will have noticed that I skipped over many of the metals. This is because there is no pattern to determine the charges of the ions of these metals. Not only that, many metals form different ions with different charges. We need a way to differentiate, for example, between an iron oxide formed with a +2 iron ion or a +3 iron ion, because just saying iron oxide is not specific. For these types of ions, we use Roman numerals to designate the charge of the cation. So iron 2 oxide is formed between an Fe2+ cation and an O2- anion. Iron 3 oxide is formed between an Fe3+ cation and an O2- anion. In order to balance the charge, the formula for iron 3 oxide is different than the formula for iron 2 oxide. If you are looking at the formula, you can tell the charge of the cation from the charge of the anion. Here are examples of 2 types of lead chlorides. The first requires 2 chlorides to balance the charge. The second requires 4 chlorides to balance the charge. This means that the charge of the lead ion in the first compound needs to be +2, and the charge of the lead ion in the second compound needs to be +4. This table shows ions that form only one type of ion. Thinking back to the pattern previously discussed, Pause the video here and try to guess what the charges of these ions will be. Notice that zinc and cadmium will always have a charge of +2, and silver will always have a charge of +1. Therefore, it would be incorrect to call these compounds zinc 2 oxide or silver 1 chloride. Instead, we just call them zinc oxide or silver chloride because there is no need to specify the charge. Next, we will talk about ionic compounds that are formed with polyatomic ions, which are charged molecules that are made up of more than one atom. The atoms in a polyatomic ion are covalently bonded together, but they behave as one unit, so you should think about them as individual ions. The names and charges of some of the most common polyatomic ions are shown here. Notice that there are some patterns to the way these ions are named. The ions with fewer oxygen are given the "ite" suffix, and the ions with more oxygen are given the "ate" suffix. There are 4 polyatomic ions that contain chlorine and oxygen atoms. The one with the least amount of oxygen is given the prefix hypo, which means beneath. Hypochlorite has the fewest oxygen atoms. Chlorite has one more oxygen atom than hypochlorite. Chlorate has one more oxygen than chlorite, and perchlorate has one more oxygen than chlorate. The prefix per comes from the word hyper, which means above. This pattern also holds with bromine and oxygen-containing polyatomic ions. Once we know the names of polyatomic ions, naming compounds formed with these ions is easy. There is no need to change the names or add prefixes or suffixes. Here are some examples of some named compounds with polyatomic ions. Notice how we still use the Roman numeral designation if the cation is one that requires it. Sometimes it may be necessary to use multiple polyatomic ions to balance the charge. If this is the case, we use parentheses around the polyatomic ions and include the appropriate subscript. Some examples are shown. Next, we will discuss naming acids. Acids are special compounds where the cation is a hydrogen ion. Hydrogen ions always have a charge of +1, so acids will have a different number of hydrogen depending on the charge of the anion. Binary acids are acids where the anion is a single atom, not a polyatomic ion. Binary acids use the prefix hydro and the ending "ic" acid. Here are some examples of named binary acids. If the anion is a polyatomic ion, the rules are different. The name of the acid depends on the anion. If the ending of the name of the anion is "ate," then the name of the acid will end in "ic." If the ending of the anion is "ite," then the acid will end in "us." A helpful way to remember this is to recite the phrase, "ate goes to ic, ite goes to us." For example, the acid made from the phosphate ion is called phosphoric acid, and the acid made from the phosphite ion is called phosphorus acid. Finally, we will talk about naming covalent compounds. Covalent compounds are formed between nonmetals. Electrons are shared between atoms, and in covalent compounds the charges don't balance in the way that they do in ionic compounds, so you do not want to think about how to form neutral molecules for these types of compounds. When we name covalent compounds, we need to state the number of atoms that are a part of the compound. There are a lot of different compounds that can form between nitrogen and oxygen, and we can't call them all nitrogen oxide. In order to be specific about which compound we mean, we use numerical prefixes. Nitrogen monoxide is composed of one nitrogen atom and one oxygen atom. Nitrogen dioxide is composed of one nitrogen atom and 2 oxygen atoms. Dinitrogen monoxide is composed of 2 nitrogen atoms and 1 oxygen atom, and dinitrogen tetraoxide is composed of 2 nitrogen atoms and 4 oxygen atoms. Here are the numerical prefixes for the different number of atoms and some examples of covalent compounds. If the formula is given, try to determine the name of the compound. If the name is given, determine the formula. Pause the video here until you have arrived at your answer. For extra practice on chemical nomenclature, you can find practice questions along with the solutions in the description of this video.